Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to play with some signal generators. I noticed that when I do signal generator videos they do seem to prove quite popular, so hopefully this one will be helpful too. So let's go to the bench and play with some signals. Okay, so here's the setup then. Got Siglent SDG 1032X signal generator and the Yuntec JDS 8080 signal generator here. This one I purchased a couple of years ago. This one was sent to me for reviewing. There is a review video, I'll put a link up the top to that for you. And here is my spectrum analyzer, which is the Siglent SSA 3021X. And currently I've got it displaying a signal, but it's not coming from either of these two signal generators. So let me explain. So the arrangement I've got is I've got a 1k resistor as a load I'm going to use to feed the signals into, and I'm just sampling off that load using an oscilloscope probe, so we're just keeping a nice low input to the spectrum analyzer. Okay, so currently you can see it's got quite a slow update rate, which isn't surprising really, because the span here is 100 Hertz, so each division 5 Hertz. And what I'm going to do now is I'm going to just move on to the trace menu, and we'll move across to the green trace, and what I'm going to do is just get that to sample what's coming in there, and then we'll get that to hold like so, and then we'll go back to that one. We'll just for a moment get rid of that. So that held trace we've got there, which is coming in, he's coming in from a little module that was very kindly donated to me by, I think it was Paul L or Paul M, forgive me, I can't remember off the top of my head, and it's just a little GPS signal module. Here's a picture of the board that he used to produce the little module, and all it does is it listens to GPS satellites and produces a very accurate reference, and in this case he's got programmed to produce 10 megahertz. So I've got the 10 megahertz signal coming into the spectrum analyzer, and I've had all of these instruments and also the GPS module, I've had them switched on for a couple of hours, so they're definitely warmed up. So what we've got here is the center is 10 megahertz and the peak is what's coming off the GPS module. Now you can decide excuse me, you can decide which is wrong. I'm sure there'll be somebody very keen to point out my errors to me, but I think the peak here, which is actually about, I don't know, maybe a couple of hertz below the 10 megahertz line on the spectrum analyzer, I think the peak is about as accurate as I'm ever going to get. And what that's saying is that the spectrum analyzer is just a couple of hertz out. Well, okay, that won't matter a fig to me. It might to some professional lab, but it certainly doesn't to me. So I think first thing to say is this is pretty accurate. Now I'm going to leave that green trace on there as a reference, and now what I'm going to do is I'm going to disconnect the, if it'll let me do it, disconnect the GPS module. I'm going to connect up the Sigland, and I've got it set to put out 10 megahertz at 1 volt peak to peak, so we'll switch that on, and we'll turn on clear right for the yellow trace and just let that settle down. You're getting such a slow update because of the very small span across the screen. It's 100 hertz, and what that's essentially saying is that the Siglent is reading about 10 hertz, or is outputting a signal that's about 10 hertz underneath, maybe 9 hertz underneath the GPS reference. So in other words, really good. Now we'll come back to how you can make some adjustments there, but let's have a look what the the Yuntec makes of that. So we'll just switch off that and we'll move the output now onto channel 1 of the Yuntec, and that's already enabled. Again, 1 volt peak to peak, 10 megahertz, and there's nothing there. So what I'm going to do is I'm going to zoom out, because actually the peak is there. Now I've gone to 200 hertz span, so that is 1, 2, 3, 4. That's about 40 hertz low as it stands. Now it's actually extremely easy to adjust the Yuntec to allow for that if you've got a reference. But as I say, both those have been switched on for a while, so as it comes out the box, this indeed comes in at about 40 hertz underneath. So very easy to say, oh well, what do you expect? You know, you get what you pay for. This was a lot more. Yeah, that's probably got something to do with it. But I come from a time where we would have dreamed of equipment like this to be able to play with, and 40 hertz, quite frankly, was really very close. So both of them, yeah, you know, pretty good. I think the other thing to say is that these are probably about less than half the price of that, and remember that's a 30 megahertz generator. This one is capable of 80 megahertz, so it's got a lot more range. Okay, so let's now get set up to do something else, and to do that I'm just going to by the magic of film mating. Okay, so I'm still set up here on the Yuntec, and what I've now got is a lead that's going from the external input on the Yuntec, and I'm going to plug that into the GPS reference. Appreciate that's probably just off camera, but just have to take my word for that. So it's connected to the GPS reference, and as you can see it's still on its internal oscillator, so it's still showing about I don't know, 40, where are we? So, sorry, 2, 4, 6, about 80 hertz low, not 40. I was talking rubbish last time. It's 20 hertz per division at the moment. So now what we can do, we can go on to the system menu and page down, and we've got here external sync. So let's go down to external sync and let's turn it on, and if you watch this peak, and there you can see the Yuntec is now taking its reference from the GPS, and clearly it's now got a much more accurate result. So that definitely says for sure, yeah, the internal oscillator in here as it stands is a little bit out. So if we turn off the external sync, there it is, back down to there. Now there is also, while I'm on this screen, and it's just easy to show you, there is also a frequency fine-tuning setting on the Yuntec. Now it comes set as at 50, but it's adjustable, so if we select that and we now turn this knob, remember this is taking just a little bit of time to update. It's taking just under a second for each sweep, so we can wind this up now. When you get to about, I think it's about 62 off the top of my head, a little bit more than that. There you go. So I'm going to stick with 65. That's in fact, if I go to 64, it's probably slightly lower than the centre. So I'll stick with 65. So at 65, that's, if you like, an offset that is effectively moved the Yuntec back onto frequency, and we can save that, and then we've got the ability to then use the system. As I say, we're using the external we're using the internal oscillator at the moment, but if we turn on the external oscillator, there's, you know, virtually no change. A little bit more phase noise, but essentially there you go. So certainly possible to get the Yuntec spot on if you're unhappy with it being a few hertz out. Let's now get set up and look at what the Sigland does on that score. Okay, so I'm now attached to the Sigland with the output, and I've got the external synchro connected to the Sigland, but currently it's running off its internal oscillator. So if we enable the output, 10 megahertz, as you can see, we're getting that display similar to we got before, and I can actually zoom in here to make it 100 Hertz span, so you can see that we're just well, that's 5. Yeah, we're about 7 or 8 Hertz low on the frequency. So let's now here on the system menu, we've got source, internal or external. Currently it's on internal. Now for some reason the Sigland isn't entirely happy with the output from the GPS clock, so it will squeak a bit and probably cut the output off, but it does sort of work occasionally. It probably needs a slightly higher signal. Let's just now go to external. Now it's saying it's not valid, but actually as you can see it's working, because it has actually, well, it's turned it off now, but it does actually momentarily display you a signal there which is actually on frequency. And if I go to trace and just view that, and I'll just stop the beeping if I can. There we go. So I've just paused both traces there. So the green is the one that was coming off the SAT, and when it's working on external reference, that's the yellow traces, the Siglent. So both are capable of being brought in line with the reference using the external reference, which I know is the kind of thing that a lot of people are keen on and gets done in labs. For me, it's way more accurate than I'm ever going to need, but the facility is there. Now I've been looking through the Siglent manual, and I've yet to spot where you can adjust the internal oscillator. I'm sure you can, I just haven't found it yet. So if you know how to do that, perhaps you can put it in the comments, and that'd be useful for everybody. As I say, I'm sure it is there, but it's just for once nowhere near as intuitive as the Yuntec there, which was much easier to find and adjust the frequency offset. So there we go. That's accuracy of frequency. Let's have a look now at the outputs of these two instruments across the frequency spectrum. Okay, so a bit of a rearrangement gone on. Still got the two signal generators, got them both working off their internal clocks now, and I've reset the spectrum analyzer, so we're reading between 0 and 10 megahertz, and I've got both generators set to produce a 1 megahertz sine wave at 1 volt peak to peak. So we'll start first of all by looking at the Yuntec, and we'll see just how clean the output is. So let's turn channel 1 on, and there's the fundamental, as you can see, at 1 megahertz, and there is a harmonic there. It's well down on the fundamental, but it is definitely there, and so I think that's actually a pretty clean output. Let's just compare that to the Sigland. Let's again 1 volt peak to peak, at 1 megahertz, and there's your Sigland, and the thing you can see straight away is there is no harmonic there. Now I'll come back to that in a minute, but I think it's perhaps, I'm sure there'll be a few people watching now saying, well, what do you expect, that's cheap Chinese? Well, this is expensive Chinese. They're both made in China. Yeah, no question that the Siglent's a better instrument. Whether it's more than you need for the home lab is questionable. It's probably more than I need. This was just a bit of a treat to myself. But yeah, we've got no obvious second harmonic there. And if we just go back to the Yuntec for a moment, if we now increase the amplitude, so that's 2, 3, 4, so at about 5 volts peak to peak we're showing some other harmonics now, and you can see there's a couple up there as well which vanish when you turn the voltage down, and whilst in one sense harmonics are a bad thing, if you want a reference signal that's beyond, say, the 80 megahertz of this particular instrument, sometimes the harmonic can come in quite handy if you want to generate a marker somewhere up in UHF or whatever. So I'm not saying it's a feature. In one sense, it's the output is not as clean, but when you're down to 1 volt peak to peak, sorry, there's 1 volt peak to peak. Yeah, there's a very small harmonic, but it's certainly not something that I would consider an issue. So, just back to the Siglent for a moment, with its nice harmonic free output. Now, being a more expensive instrument with more features, it actually has the ability to produce harmonics for the very reason that I've just mentioned. So we can turn harmonics on there, and we can, if we go to parameters, we've got type, order, amplitude and phase. So if we go to type, we've currently got the even harmonic. We can go to the odd harmonic there, so odd, even, yeah, and all. And then if we so desire, we can also set the harmonic order. But for now, I think it's enough to show you that yes, you can produce harmonics if required, or turn them off as is required, and that's, I'm presuming, for that very reason, to allow you to make use of the harmonics if that's something you're using it for. So there we go. That's output of the two generators, and I've just used 10 megs there because this is only a 30 meg generator and this is 80. But I think it's probably worth saying, and you're probably familiar with this already, but if we choose a square wave, we of course get plenty of harmonics. The sharp edge does indeed produce lots of harmonics, and if we choose to make the stop frequency there 100 megahertz, you can see we've got harmonics going right up to 100 megahertz there, no problem, which is the noise of the square wave. And if I hop back onto the Yuntec for you and change that to, if I can remember how to do it, square, you can see we also get the harmonics running across there, although they're not as pronounced. So let's just turn up the amplitude a little bit. Yeah, so you need to turn the amplitude up a bit, but you can get harmonics from the square wave. But interestingly, the depending on whether they're odd or even harmonics, they're different strengths on here, whereas on the Siglent, yeah, we've got the multiples are a similar level. You can see there those set. I'm being careful not to touch that because it's a touch screen. But there you go. Yeah, that's the two generators put through the paces a little bit, and yeah, I think, yeah, paid a lot of money for that, but it's very nice and it's got lots of features this doesn't have. But I also think that that machine's pretty capable, and if that was all I'd got in my electronics lab, I'd be more than happy with it. Okay, well, there's a few rambling thoughts and ideas on my Siglent and my Yuntec signal generators. Hopefully it's been useful to you. I started tatting with electronics where the level of accuracy was nowhere near what people expect today, and either of those signal generators, as far as I'm concerned, are more than good enough for the things that I do. I'm just a hobbyist, as I often say, far from being an expert. So hopefully that's been useful, and I think it's quite handy to see how a fairly cheap satellite signal reference can be used to make both signal generators more accurate. And ironically, the cheaper of those two generators, the Yuntec, is the one that's easiest to adjust in software, so that you get something that works pretty much close to spot on when you switch it on. Yeah, it's not perfect, but it does the job. Hope that's been useful. Thanks very much for watching, and look forward to seeing you on the next video.